what you found in that blue worksheet is what we call the law of sines, okay? In your notes, you may want to write it down, whether you write it down as 3 separate equations, or if you want to write that they're just all 3 equal to each other, and no, you can pick any of the 2 to set equal to each other. I don't care how you write it, but this is what we need to know as far as the formula is concerned. Okay, so I'm not just telling you a formula, you actually came up with it on your own. Okay, I gave you some prompts and you solved for it. Okay, so this isn't just a random formula that I'm throwing out at you. Okay, it's actually one derived from right triangle trigonometry, but it's going to help us with triangles that are not right triangles. Before moving forward, let's just remind ourselves the difference between uppercase letters and lowercase letters. Uppercase letters represent what on a triangle? Angles. And lowercase letters represent sides. Remember, they're always across from each other. Angle A is across from side A. Okay? Now, what is the purpose of these formulas? Okay, I prefaced it a little bit at the beginning, but the whole purpose of the law of sines, and then eventually the law of cosines on Monday, we need to be able to find the measures of sides and angles in a triangle. Okay, now we know how to do that for right triangles, but law of sines and law of cosines will help us find measures of oblique triangles. So those triangles that are not right triangles. Now, we can't use the law of sines on just any oblique triangle, okay? First of all, we do need 3 pieces of given information in order to solve for the other 3 pieces, okay? There's 6 pieces of the triangle total, 3 angles and 3 sides. We need to be given 3 pieces of information to find the others. So specifically, in the case of law of sines, these are the 3 different scenarios that we can have in order to be able to use the law of sines. Okay, we can have 2 angles and a side, whether it's angle side or angle side angle, or we could be given 2 sides and an excluded angle, side angle. I know this gives you a flashback to geometry, right? We are not proving triangle congruence, and we are not proving triangle similarity. These are just the pieces of given information we need in order to be able to use the law of sines.
We're never going to see, so like, say it gives you sine based on a B, or we're going to see like side C, and or the all going to be like part of B.
Okay, so it's because I had the 3 equal to each other? Is that your question? Okay, so we're going to use them like this, where we're going to pick 2 of the 3 to set equal to each other and solve. Pick 2 of the 3 set equal to each other and solve. Okay, we know that all 3 are equivalent, but we're just going to pick 2 at a time. Does that answer your question? Okay. Okay, today specifically we're going to focus on these 2 cases right here, 2 angles and a side. So when I talk about angle, side, that means I have a triangle where I know 2 of the angles and the side is not in between them. Versus angle, side, angle, where I know 2 of the angles and the side is in between them. Okay? just to paint you a picture. Tomorrow, we are going to talk about the side-side angle case. It's actually a special case. We call it the ambiguous case because something funky happens. So we're going to dedicate all of our time tomorrow on the side-side angle case. Okay? And then Monday, we're going to talk about the law of cosines, which requires different pieces of information. Okay? Now, I do want you to have a conversation at your table. There is one case where if I give you 3 pieces of information about a triangle, you can't solve for the other 3. Brainstorm at your table what scenario that would be. I give you 3 pieces of information and you can't find the other 3. You just said that one right there.
Yeah.
Okay. Remember, law of cosines has some rules too that aren't up here. That's just like using hints. Trigger not. Okay, pod 2, tell me about your conversation.
You said angle, angle, angle.
Angle, angle, angle. I don't know why you're laughing.
No.
I just saw something. Angle, angle, angle. You're supposed to be over there.
Okay? Angle, angle, angle. Here are triangles that all have the same 3 angles. There are an infinite number of triangles that share the same 3 angles. We can't solve for sides if we're given 3 angles. Okay? Thank you for your answer. Okay, go ahead and write down this piece of given information. A is 32 degrees, B is 50 degrees, and C is 18.7 centimeters. When you're done writing it down, make sure you have your calculators out. We are solving for a triangle. Do you see a triangle?
No.
I don't see a triangle. If I'm solving a triangle, I need to see a triangle. So if there is not a picture, I am requiring you to draw a picture. It does not have to be drawn to scale, but just have it there so you know where A, B, and C are. Okay? So here's my triangle. I labeled A, B, and C as far as the angles. Angle A is 32 degrees. Angle B is 50 degrees. And side C is 18.7 centimeters. Okay? Looking at this picture, what pieces of information do we have? All right. We have 2 angles, and the side is in between. We have angle, side, angle, which means, yes, we can use the law of sines. I say that because eventually we're going to have the law of cosines, and we have to be careful of when we use which formula. Okay? So we need to solve for angle C, side A, and side B. Look at that picture. What is the easiest piece of information to solve for first? When we have 2 angles, the third angle is always going to be the easiest to solve for next. So we know that angle C has to be 180 degrees and then subtract out our other 2 angles. Help me out here, calculators.
98.
98 degrees. Okay. Okay. I know that you've had teachers that maybe ask you to like label your triangle with your answers. I like you to find your answers and circle or box them so I can find them where all of your work is. Okay. All right. Now at this point we can start to find the sides. Does it matter which side we find first? It does not, because they both have angles that are across from them that we know. So if we want to find side A first, we would have to get the ratio sine of A over side A. And if we wanted to actually solve for side A, would we pick the pair of C's or the pair of B's? We need the pair of C's because we know both of the C's. So we're going to set this equal to the sine of 98 degrees over side C, which is 18.7. Okay? Now, we have a proportion. You all have solved proportions many times. I'm going to go through the work step by step, but then there's going to be a point where you've done this so much where you write this, because you need to at least show me how you set the problem up, and then you're going to plug into your calculator. But don't forget that when we solve proportions, we're going to cross multiply. So A times the sine of 98 degrees equals 18.7 times the sine of 32 degrees. Before you start typing away, please make sure you are in degree mode. Make sure you are in degree mode. And then what I'm going to type in is 18.7 times the sine of 32. And then notice how the sine of 32, it opened a parentheses. I'm going to close that parentheses. And then I know that in order to solve for A, I need to divide that sine of 98 over. So side A is 10.01 centimeters. Now, our last job is to find side B. So we need to set up that the sine of angle B over side B equals. Here is my word of warning. Side A, we rounded off. Do you agree? It wasn't exactly 10.01. We rounded it. So I would avoid using it if you can. Can we avoid using it? Yeah, we can set this equal to the sine of 98 over 18.7, and we're not using any rounded off answers. Sometimes we have to use our rounded answers, but if we can avoid it, I would. Use as much given information as possible. So what would that give us for side B? Okay. Notice how I have my picture drawn and labeled. I have set up, work, and answers, but at the very least, set up and answers. And my answers are very easy to find because I circled, or in this case, I put a rectangle around them. Okay. One more thing before we end for the day. How do we find the area of a triangle? 1/2 base times height. We've been doing that since what? Elementary school? Okay. Now, is it always convenient, or do we always know the base and the height of a triangle? Okay. Sometimes we don't. If it's a right triangle, automatically we're going to know those. But if it's an oblique triangle, sometimes even finding the height is a pain in the rear. Okay, we can be honest, right? Sometimes finding an altitude is not convenient. Okay. So, in this chapter, they have developed 2 area formulas based off of our knowledge of right triangle trig that actually allow us to find the area of a triangle, not knowing the base and the height. Okay. The first is this formula right here. So area of an oblique triangle, I would just focus on writing this down right here, along with side angle side. If you know side angle side of a triangle, we can find its area with this formula here. I'll have you write it down and then I'll explain why I have 3 formulas up there. So I have those 3 formulas up there because those are just the different cases of side, angle, side. But no matter what, if you have a triangle and we know side, angle, and then a side, we are going to take 1/2 times the 2 sides times the sine of the angle that is in between. Okay? So it doesn't matter A, B, C, D, E, F, G, whatever. Okay? 1/2 times the side times the angle in between. A lot easier than trying to find the height, right? We don't have the height, but we know 2 sides and the angle in between. This is going to be a lot easier for us, okay? I'd love to show you for the proof of this, but I don't think we have time. And I don't know how many of us care today. Right? It's almost spring break. You're like seeing the line. Okay, so this is our last example. What I would do, let's just draw the triangle and label it together. C is 102 degrees, B is 52 meters, and A is 90 meters. Is that triangle drawn to scale? No. Not even a little bit. I don't care if your triangle is drawn to scale. I just want you to have a triangle labeled with the vertices so that you can see where the sides are and the angles. Okay? Since we know side, angle, side, our area is 1/2 times the 2 sides times the sine of the angle in between. What, woman?
The formula's good. So why did you just use the 2 sides? Because it said, the formula said BC. And then sine of A.
Well, but this formula says like A, B, sine of C. So we're using A, B, sine of C. Okay? Don't get stuck on the letters. Okay? So did anyone type this in their calculator? Nobody?
It's 2,288.
And since our sides are meters, then this is going to be square meters. Okay, chapter 6 is an opportunity for you to reflect on, okay, what do I need to change about my work habits so that chapter 6 can be better? Okay? Come talk to me if you'd like to schedule a time to get help if you're taking a retake, or to get suggestions on some things that you can do to change your work habit.